Hi students. In this lecture, I am going to discuss problems from Irodov. Let us see first one. See the question given. A uniform thin rod AB of mass 1 kg moves translationally with acceleration 2 meter per second square due to two anti-parallel forces F1 and F2 as shown. The distance between the points at which these forces are applied is equal to 20 centimeter. Besides, it is known that F2 equal to 5 Newton. Find the length of the rod. Let us see how to start. First, make the diagram given. It is a uniform thin rod. Uniform thin rod. Forces are given F1 and other is F2. And the separation between those two is given as 0.2 meter. 20 centimeter means 0.2 meter, and acceleration is 2 meter per second square. Acceleration is 2 meter per second square. And it is also given that F2 equal to 5 Newton. And see what we have to calculate. Length of the rod, how much? So rod length is how much? So F1, F2 anti-parallel. Separation between those two is given. Acceleration 2. F2 value is given. We have to find length of the rod. Now see here key points to start the problem. So it is given that translationally means the rod is having only translatory motion. There is no rotational motion. That means there is no torque. Okay. So first thing we have to focus. Net torque must be 0. Okay. And here we are saying that since having translatory motion, center of mass moves with acceleration 2 meter per second square. So we are taking motion is always as a combination of motion of center of mass and rotation about center of mass. Now in this case, about center of mass, there is no rotation because it is given translation. Okay. So first thing here, F2 minus F1 equal to MA. That is one possibility. Otherwise, we can write F1 minus F2 equal to MA. That is a second possibility. So first we have to decide which is the correct one. Is it F2 minus F1 or F1 minus F2? Okay. So for that, what we are doing is about center of mass, there is no torque. It is about center of mass, there is no torque. Because in this, net force is not 0. When net force is not 0, net torque is not same about any point. So from point to point, it will change. That's why I'm saying net torque about center of mass is 0. Okay. Let us take center of mass somewhere here. I'm taking outside those two forces. This is center of mass. See why I'm taking center of mass outside. The reason is that if I'm taking center of mass somewhere here, Because of F2, torque will be clockwise. Because of F1, torque will be anti-clockwise. Because we are calculating torque about center of mass. Since directions are opposite, they can balance each other. So now here net torque must be zero about center of mass. That means center of mass must be outside these two forces. That is our first conclusion. Second conclusion is, since F2 is closer to center of mass, F2 must be having more value. The reason is that, suppose this is now X. Okay, then I can write. So here I'm writing torque about center of mass equal to 0. Because having only translatory motion, then torque due to F2, F2 into X. This must balance torque due to F1, F1 into F1 into L by 2, right? You can see X is less than L by 2. That means from this we can say F2 must be greater than F1. Then only this is possible. I am repeating from diagram. X is less than L by 2. That means F2 must be greater than F1 to make net torque 0. That means we have to write equation F2 minus F1. This is net force, which is equal to mass into acceleration. Okay. And F2 given how much? 5. F2 given 5. This is 2. 5 minus 2, 3. So this implies F1 equal to 3 Newton. Okay. Now just substitute value here and we can get the answer, right? See what we get. F2. F2 is now, so F2, what we can write here? F2 5. 5 into X is nothing but, X is nothing but, it is, X is nothing but L by 2 minus 0. See carefully. From center to this end, L by 2, total value L by 2. This is given 0. So remaining how much? L by 2 minus 0. That is equal to, F1. How much we got? 3. 3 into L by 2. Okay. So 5 into L by 2 minus 3 into L by 2. That is equal to 5 into 0.2. It is 1. That means its length equal to 1 meter. Okay. So here key point is that first we have to identify which one is more. Is it F1 or F2? And that we are deciding from the condition that about center of mass torque must be 0. From this we conclude F2 should be greater than F1. That's why we are writing F2 minus F1 equal to MA. Okay. Let us see next one. Let's see the question given. A uniform board of radius r rolls without slipping down from the top of a sphere of radius capital R. Find the angular velocity of the board at the moment it breaks off the sphere. The initial velocity of the ball is negligible. Okay, given uniform ball, right? We have to find angular velocity of the ball at the moment it breaks off. Breaks off means losing contact. Let us see. So first make a diagram. It is a sphere. Now there is a one smaller sphere on the top, which is rolling without slipping, which is rolling without slipping. You can see at one point of time, it will lose contact. Let us say at that time, the line joining centers makes an angle theta with what? Okay. So BCM will be like this. Rotation is now like this. Okay. See here what we are doing. If you remember, almost same kind of question we have solved in work energy power. There we have taken a block is sliding, means having only translatory motion. Now here only extra part is it is also rotating. Okay, that is the only change. So the first condition, it breaks off. Okay, breaks off means losing contact. You can see the center of the sphere follows now settler path. Settler path of radius r plus r. This is a capital R and this is smaller. See carefully. Center of the sphere follows settler path of radius r plus r. Okay. And if you take here mg vertically downwards, I will draw here mg, mg vertically downwards. It's a component towards the center that provides now centripetal force, which is equal to mg cos theta. This is now providing centripetal force. Okay. So which is equal to mass into centripetal acceleration. So m into bc square by radius is now r plus r. So first condition is at the time of losing, there is no normal reaction, only weight mg. Its component is now mg cos theta. This is providing centripetal force that is equal to mass into centripetal acceleration. Okay. Now we can see in this number of unknowns, theta and bc, speed of center of mass. Okay. So now we require one more condition. So here it is now rolling without slipping. There is no loss in the mechanical energy. So I can write here loss in the gravitational potential energy. Let us see initial height r plus r, finally height equal to r plus r into cos theta. So it has come down. So loss in gravitational potential energy is mg into r plus r into 1 minus cos theta. See carefully. Initial height r plus r into 1. Final height r plus r into cos theta. It has come down by a distance r plus r into 1 minus cos theta. So mg into h. This is loss in gravitational potential energy. This loss converts into kinetic energy because of rolling motion. Half m vc square into 1 plus beta. Since it is now solid sphere, beta value 2 by 5. So 1 plus 2 by 5, it is 7 by 5. So earlier we have learned that energy in rolling motion is half m vc square into 1 plus beta. Here assumption is whenever BC equal to R omega, only in that case we can write 1 plus beta. Okay, right. So now we are focusing. See, we have to get omega equal to VC by small r. Okay, that means we have to get the value of VC. That means eliminate cos theta. Okay, otherwise expand this mg r plus r minus mg r plus r into cos theta, that is equal to how much? 7 upon 10 mvc square. Okay. Now in the place of, see carefully, in the place of mg into r plus r into cos theta. See here, equation 1, mg into r plus r into cos theta. I can write in this place, it is mvc square. In this place, mvc square. So mg into r plus r is equal to, this is 7 by 10 plus 1. How much? 7 by 10 plus 1. That is equal to 17 by 10. 17 by 10 mvc square. Okay. See what I'm doing here. mg into r plus r into cos theta. mg into r plus r into cos theta equal to mvc square. Okay. M gets cancelled. From this VC value 10 into G into R plus R upon 17 under root. Okay. Now omega equal to VC by R. So omega equal to take by R. Then that becomes 10 G R plus R upon 17 R square. Right. So we have taken one is force equation. The second one is energy equation. Right. Let us see next one. And see the question given. Determine the kinetic energy of a trajectory, sorry, not trajectory, of a tractor. It is tractor. TRACTOR, tractor crawler belt. So change this one, tractor crawler belt of mass M. If the tractor moves with velocity V as shown. Okay. This is not trajectory. This is a tractor. Okay. Tractor. Given it moves with velocity v as shown. Now see carefully here. This is a belt. Okay. A belt is now like this. If you observe, we can say JCBs. You're having a belt like this. Wheels will move inside. And if you observe carefully, the part of the belt which is in contact with the ground, that part is always having zero velocity. I am repeating, the part of the belt which is in contact with the ground is always having zero velocity. Okay. If you have that point, if you are knowing that point, remaining only is simply calculation part. Let us focus how to solve it. So see diagram given. This is a belt and having here one wheel like this. So completely one belt. And there are two wheels. Right. So we have to find now kinetic energy of the belt, right? Determine kinetic energy of tractor crawler belt. Belt kinetic energy we have to calculate. Now see what I am saying here. The part of the belt which is in contact with the ground that has no velocity. Let me mark it as AB. The part AB having zero velocity. CD. This part having velocity 2v, because we have learned that whenever a body rolls without slipping, this is rolling on ground. If this velocity VCM is v, for topmost point velocity 2v, for bottommost point velocity is 0. It is 0. So we are taking same logic here also. Okay. Now see carefully. Suppose length of AB, take it as L. CD also L. Okay. You can see A to C pi r, D to B pi r. So total length is now 2L plus 2 pi r. Okay. We are given belt mass, that is M. Belt mass is given M. Right. Let us see how to calculate now for the belt kinetic energy. So here what I am doing is first focus AB part. For AB part velocity is 0. So no kinetic energy. Now focus CD. For CD part kinetic energy of corresponding mass. Let us take lambda, mass per unit length. Mass per unit length. Half lambda L, that is mass of CD, half m v square. V value 2v whole square. This is for CD. For AB 0. Okay. For AB 0. Now coming to AC and DB. What I am saying is this half part of the belt, it makes one complete belt. I hope you are getting this point. I am saying that D to B, this is a half part of a belt. Semicircle. CA also semicircle. This half belt makes one complete belt. It is just like one ring, right? For a ring which is rolling without slipping, kinetic energy will be half into m into vc square into 1 plus beta. Writing same here, half. Mass is, length is pi r. This also pi r. So total length is 2 pi r. 2 pi r into lambda. That is now mass of that ring. Okay. I'm showing here. This is half part AC, half part BD. Okay. Half m b square into 1 plus beta for ring, beta value 1. I hope you are getting this point. So what I have done here, for bottom, no velocity, no kinetic energy. For top, half lambda into L, mass of CD, half into m into square of 2v plus AC, half part, BD, half part. That two half parts will make one ring. This ring is now rolling without slipping. Then for that ring, kinetic energy will be half m v square into 1 plus beta. This is the kinetic energy of that belt. Remaining just a calculation part. See carefully. This is a 2. This is a 4. 2 square. 4 by 2, 2. Okay. Or I can do one thing here. Lambda v square taking outside. Lambda v square I'm taking outside. Remaining is now 4 by 2 to 2L. This is 2L plus here 2 and 2 gets cancelled. Lambda is taken outside plus 2 pi r. Okay. And we have seen here lambda into L, that is equal to M. And lambda, see L is how much? 2L plus 2 pi r, right? 2L plus 2 pi r. This is lambda into L into V square. Lambda L. What is that? M. It is M V square. That is now kinetic energy of the belt. Okay. So I hope you got it.